Right, okay. Right, good afternoon everybody. I'm Paul Grant, I'm from Glensound Electronics and I'm Chief Engineer there. And today we're going to talk about HD Voice, which is a new system for mobile phones. So in this presentation we'll look at what is HD Voice. We'll take a brief look at the history of telephony and why we're limited to 3.5 kilohertz. We'll look at the evolution of codecs, how we've got to where we are today and why HD Voice was developed. We'll look at how HD Voice compares with previous codecs. We'll look at how it works in practice, how you can use it as a broadcaster, the availability, which networks it will work on, solutions for broadcasting, and we'll have a brief listen to a sample of HD Voice as used in a real broadcast environment, and then a summary and questions. So first of all, what is HD Voice? Well, HD Voice is actually the commercial name for the G.722.2 AMR wideband codec. Obviously rather a mouthful and not very consumer friendly. So the telecoms companies wanted a unified name which described AMR or wideband in terminology familiar to consumers. HD is commonly accepted as the symbol for high quality and therefore was the obvious choice for them to use. So it was developed to overcome the limitations of standard telephony, which as we all know gives you 300 Hertz to 3.5 kilohertz roughly. And it's been that way really for the last 50 years. So HD Voice extends the coverage at the low end down to 50 Hertz, giving you a much more natural sound, and at the high end up to 7 kilohertz. The frequency response is broadly similar, of course, to G722 that we're probably all familiar with. So, as I said, a brief history. The reason we're stuck with 3.5 kilohertz audio is that early analog telephone systems used frequency division multiplex to squeeze a lot of voice channels into trunk circuits. The frequency of separation used in the carriers was 4 kilohertz, and therefore this restricted the audio bandwidth because of filtering to about 3.5 kilohertz. Digital telephony was later developed but had to interwork with the old analog technology. 8 kilohertz as a sampling rate, of course, gives us roughly 3.5 kilohertz of audio bandwidth, so matches in with the older systems nicely. It's also a multiple of 4 kilohertz, so it reduced interference with the frequency division multiplex systems. So historically, that's why those sample rates were chosen. When the mobile phone networks emerged, it made a lot of sense, especially given the limitations of the technology at the time, to use exactly the same sample frequencies and of course the same audio bandwidths. So, codecs used within the mobile phone networks, we won't talk about the very early systems, but starting with GSM, the data channels that you had available to you were either full rate of 13 kilobits per second or half rate of 6.5 kilobits per second. The lower rate was introduced to enable mobile phone companies to reduce congestion. When you had a lot of traffic, it meant you could squeeze in another set of phone calls and of course gain revenue from it. So the early GSM codecs were appropriately named full rate and half rate and used a form of coding called linear predictive coding. In 1997, this was changed to an enhanced full rate codec. This incorporated the previous codecs and added a codec with better quality. With the introduction of 3G UMTS, the AMR codec was introduced. You see it here as AMR narrowband. This is a consequence of AMR wideband coming along and the need to distinguish between that and the older system. So AMR narrowband stands for Adaptive Multi-Rate Narrowband. It used an ACALP or algebraic code-excited linear predictive algorithm. Again, as before, it worked with an 8 kHz sample frequency, giving you 3.5 kHz of audio bandwidth. As I said, this again has to squeeze into the existing GSM channels, so it runs at bit rates from 4.75 to 12.2 kilobits per second. It's worth mentioning at this point that the algorithms chosen for mobile phones were designed very much with the fact that the radio interface was not necessarily going to be completely reliable. So there are a lot of techniques built in that enables the air interface to protect the most important parts of the data within the codecs. This is an essential difference between using a radio system and something like ISDN, which we're all familiar with as a fairly robust data medium. So I think the telecom companies are perhaps a little embarrassed that in the last 50 years there's been no real improvement in the quality of phone calls, certainly in terms of frequency response. And I think both the manufacturers and the telecoms providers felt that there was a need to do something about this in an age where we have high definition television. So they introduced this new codec called AMR wideband, which stands for Adaptive Multi-Rate Wideband, the technical name of which is G.722.2. Worth pointing out that although it's G.722, which we're all familiar with, the codecs bear very little resemblance to the G722 that's used in ISDN. They are much more sophisticated algorithms with much lower bit rates. It uses a speech coder very similar to the ACALP processors used in AMR narrowband, but with some differences. The main difference with AMR wideband is that it uses a fixed sample frequency of 16 kilohertz. This enables us to get a 7 kilohertz audio bandwidth. And at the same time, they extended the low frequency end down to 50 hertz. 300 hertz, of course, always makes audio sound rather thin, despite the fact that it's got a limited upper band. 50 hertz makes it sound much more like natural voice. Again, bit rates run from 6.6 kilobits to 23.85 kilobits per second. The higher bit rates are not used within the mobile phone network. The AMR wideband codec is intended for use in other systems as well as mobile phones. It can be used for storage and use in other data transports. So let's go on to the next slide. So there are 3 different configurations that can be used within the mobile phone network. At the moment, they only use configuration A, which is actually known as the anchor rate. This rate is chosen because it will fit into the 13 kilobits per second familiar to GSM, which would allow interworking with GSM networks, although GSM is an old technology and it is unlikely that they will go to the trouble of upgrading. Now, at 12.65 kilobits per second, the rate that's used as standard in mobile phone networks, you get a quality equal to or better than G722 running at 56 kilobits per second. Now, we're all familiar with it running at 64K in ISDN networks. If anybody's ever listened to 56K working, say, with America, you'll find that there's not a great deal of difference. It's a very tiny difference. The network can reduce the bit rate, which will of course reduce the quality, although you will still get the same 7 kilohertz audio bandwidth, and it will do this only in a temporary mode to cope with poor radio conditions. So if you were to move into a slightly dodgy radio area, it will fall back but should recover. and there is indeed one even lower rate. But again, you can expect this to be temporary. However, even the intermediate lower rate still gives you a G722 equivalent of 48 kilobits per second. So I'm sure you'll agree it will probably be not much degraded over a G722 circuit. So how does HD voice compare? This graphic shows on the horizontal axis the frequency response. Obviously you've got 3.4 kilohertz down to 300 hertz for the voice band circuit. This is the way conventional GSM works. The HD voice extends that from 50 to 7 kilohertz, as we've already said. The vertical axis here shows the quality of the sound. It uses a technique called mushra. This is used within the telecoms industry and as a way of measuring subjective quality of audio. As you can see, HD voice achieves a figure of 80. This, of course, is only done at the rate you would normally get in mobile phones, not at the reduced rates. And the subjective quality of standard GSM is considerably lower at about 45. In the case of a reduction of bit rate in a poor signal area, both of these figures will reduce, so you would expect them to reduce proportionally. In other words, you will still get a better result from HD voice, but it will reduce proportionately. So what you're all probably interested in knowing is what is the difference in sound between the two?
This is an audio recording from the new Glensound MPI 004 HD reporter's mobile phone. Using Glensound HD, you are able to achieve up to 7 kilohertz audio bandwidth over a 3G network. This is a normal 2G GSM call using the Glensound GSMPI 004.
I think you'll agree that gives a fairly good demonstration of just how much better using 3G with HD voice is over a conventional call. I don't think many of us would be very happy with trying to do a commentary using a conventional mobile phone codec, but using HD voice, in fact, several broadcasts have already been done using HD voice for commentary on rugby matches. So, how does it work? Is it going to be awkward for us to use in practice? Well, the answer is no. So long as you are working currently within the same network, and you have two HD voice enabled phones, one at each end, you simply make a call in the way you would make any other call and it will connect in HD mode. If you call a phone which is not HD voice enabled or across a network where HD voice can't be passed, the call will still connect. It will simply connect at standard mobile phone technology voice band. It's worth pointing out here that the other advantage of using the voice channels as opposed to using packet data for transfer is that you get 7 kilohertz audio bandwidth, but in this case with a telephony quality of service. It connects in the same way as any other mobile phone call. Therefore, if you're in a busy area, you will find that as the traffic increases, your packet data services will become unreliable. But if you have an HD voice call in progress, you have effectively a circuit switched circuit, so your data integrity stays up. So long as you're owning that particular voice channel at the time, your service will continue at the same level. And it's worth pointing out that there was a broadcast done from Glastonbury Festival last year with roughly 150,000 people on site, all presumably updating their social network status, and the broadcast went ahead without a single glitch. My apologies, it's, as I was saying earlier, telephone quality of service is of course guaranteed. The other thing that's quite nice about using HD voice is that your normal call tariffs apply. So many call tariffs within the same network give you free calls between the same operator's phones. So therefore, once you've paid for your initial tariff, you can broadcast for as long as you like without incurring additional costs. This is not necessarily the same with packet data services. So, from our perspective, what is the problem in terms of availability? Well, the thing that limits availability is transcoding, which occurs often between networks. So in the top part of this graphic, you'll see the chain for the audio to pass. So you have an analog to digital converter running, in this case at 8 kilohertz on a standard voice band call. It goes through an encoder. This would be, of course, the standard AMR codec. It then has to go through a transcoder, and in the center of the graphic you'll see we're running at 64 kilobits per second. This would be the standard telephony network. Now obviously the standard telephony network will only run at 3.5 kilohertz, so that's the maximum quality we can achieve. Of course, if we were using HD voice, the transcoders would filter our audio down to 3.5 kilohertz, push it through the network, and at the other end, that's the best you could do in quality terms. Now, the bottom half of the graphic shows how HD voice works. In HD voice, the center section is now within the same network and is a transparent circuit. So the full 13 kilobits per second is transferred transparently between the two phones, and therefore HD voice code continues without any interruption or transcoding. So current UK voice availability is on the Orange network and the 3 network. This is set to change soon as other networks will start to adopt the technology. I believe the O2 network is unlikely to upgrade due to the fact that it's one of the older networks and they have compatibility issues. Currently there is no interworking between networks, so you must make a call inside the Orange network or inside the 3 network to make it work. Again, the telcos are intending to try and get interworking going between them. The impetus for doing this, of course, is nothing to do with us as broadcasters, but very much to do with consumers and providing a better quality of service. If your network produces a better sound quality, you're likely to tell your friends. So this shows us international availability. All of these countries have HD voice services on one of their networks at least, and new countries are being added regularly to this list. This doesn't help us crossing borders, but certainly within any particular country, if you're using HD voice, say for a talkback circuit locally, then you can buy a local SIM card and it will work. So, sort of things we can use this for in the broadcasting arena. Of course, you can do quick news reports, supply your reporter with one of these phones. If he's always got it in his kit, something impromptu happens, he can drive off to the event or travel to an incident and produce a reasonable quality contribution to cover that event. Sports commentary is another obvious application. As I said earlier, there are already live commentary being supplied for rugby matches. So again, a call back to the studio could be anywhere within the country, and you can do an hour's broadcasting without any problems at all. Other things you can do, even if you've got your broadcast truck on site with HD voice in the broadcast truck and a mobile unit for your reporter, you can go and do a pitch side interview, follow somebody down into the changing rooms, whatever. Anywhere you can get a mobile call through to, you can get a report back or an interview back. With outside broadcast vehicles, as I said, you can install a unit inside the vehicle and you can use it for IFB channels or talkback. This doesn't have to be to a broadcast mobile phone. It could be to the reporter's own HD voice enabled phone with a suitable earpiece. One of the main reasons for using a broadcast quality phone is getting the front ends right. As we all know, nothing really substitutes for a decent headset with a noise cancelling mic and professional broadcast quality mic amplifiers and dynamics processors. So as I say, in-ear monitoring. The other application, of course, which enhances your reliability, is to keep a system in the broadcast truck for backup. Worst case, if you lose all other links, you can at least get a mobile phone call back through at HD voice quality and get something on air. So what we have here is actually a short recording of live commentary from a rugby match.
Very good afternoon, Ed. And it's a lovely sunny day in London, I can tell you that. So, Tristan Roberts, right footed then. It's going to be 9 metres hot in from the right-hand touchline. One giant stride out from the 22. Tristan Roberts kicking the way to the post to my right.
Sorry about the sibilance in that. We think it may well be the particular commentator. So in summary, HD voice is a commercial name for AMR wideband codec. It gives you 7 kilohertz of audio bandwidth. The number of service providers is rapidly increasing, and it has many practical applications for you as broadcasters. Thank you for listening. It was Paul Grant of Glensound Electronics, and I'm open to questions. Sorry?
The manufacturers of telephones and consumer.
Yeah, there are a number of handsets available today which have HD voice capability. A number of the Samsung Galaxy range have it. There is a website that is worth looking at called GSACom, GSACOM.com. This is a sort of industry body, but anybody can go on there and look at the information. They have constantly updated lists of the availabilities of both networks and phones. So it's being included in standard mobile phone technology, even though not many people are actually on networks which use it. Although if you have a Samsung Galaxy and you make calls within your Orange network, it will connect to HD. Any other questions? No? You all right? Okay, thank you very much.